In the next few lessons, we're going to explore how you might find the equation of a line, even if you only know 2 points on the line. Especially if one of those points is not the y-intercept. It makes our work a little challenging, so I thought we'd explore a little bit. So to start our exploration, we're going to talk about a pool that's leaking. And the data that we know about this is an hour and 45 minutes after the leak started, we had 39 inches of water. We also know that there was 0 inches of water after 5 hours because it was completely drained. So assuming that the pool drains at a constant rate, what can we do with this? We can make a graph. We could use the graph to estimate how much water was in the pool. Assuming the pool drains at a constant rate, we could actually find the rate of change. So that's the first stuff that we're going to do, is numbers 1 and 2. So if you produce a graph to do so, you would have to start with a point 1 3/4, 39. So I go over 1 3/4 and I go up to 39, blammo, and we've got the point 50. So if I take those 2 points and draw a line between them, that represents the depth of the water at any time. Just using eyeball estimates, it appears as though there was 60 inches of water in the pool when it started to drain. But now I can prove it using the real hard data. So here's what I do. I show from these 2 points, we go from 0 to 39, we go from 5 hours to 1 3/4 hours. That's a loss of 39 inches over 3 1/4 hours time. Multiply top and bottom by 4, or invert and multiply, however you want to slice it, we're going to get negative 12 inches per hour, which is, in other words, 1 foot every hour. So, if that's true, then we'll recognize that this rate of change, that's a loss of 12 inches in a 1 hour span, that rate of change is constant, so it doesn't matter where I put it, I'll always be reflecting the change in this line. So I can actually figure out that after 4 hours, we would have had 12 inches of water. After 3 hours, we would have had 24 inches of water, and so forth. So here's how it all pans out. So just like I said, we can recognize that if we were empty at 5 hours, we had 12 inches an hour before that. And we had 24 inches an hour before that. We can keep counting, or we could say, look, there's a total of 5 hours at 12 inches per hour. Let's just work backwards. And reveal, sure enough, 60 inches over a 5 hour span. That could be seen graphically by counting backwards using our slope, or we could actually start down here and say, look, we had 0, we had 12 inches before that, and then before that we just count by 12s until we get up to 60. So for every hour we have 12 less inches, and everything is consistent. This is enough information now to create an equation. See, we know the y-intercept, which is the a value, and we know the slope is negative 12 inches per hour. So we can put that together and get y equals, or f of x equals 60 minus 12x. Or if you want your descriptive variables, you just say h of t, h for height of the water, t for time, in hours is equal to 60 minus 12 inches per hour, times the number of hours. So, now that we have that information, we can first make sure that our equation is valid. This was given information, so I cannot question its validity. This was fact. And if I put that fact into my equation should generate the 39 inches that it should, and it does. Now we could actually answer any questions. 2 3/4 hours after draining, how much water was there? Well, we just multiply 12 inches per hour by 2 3/4 hours. That's a total of 33 inches. And then we subtract that from 60 to get 27 inches. Now when I go to my graph and I find 2 3/4 hours, follow it up, and I follow it over. That is in fact consistent with the work that I was doing. So all of this is generally review. The point that I wanted to make was the idea that we can just take our known rate of change and use that to find a lot of points along a line. Take the context away, and we can do the same thing here. What I mean by that is we can actually give any point, and we can give any slope. If we know any point and we know any slope, then we can find the equation of a line that goes through that point that has that slope. So for starters, we're just going to do an exploration, and we're going to say, look, here's the point 3, negative 3, 5. And if the slope happens to be 3/4, that means I could express this in a number of ways. For example, for every 1x, the y should go up 3/4. What is that going to look like? It looks something like that. So I go over 1x up 3/4, so from 5 we're up to 5 3/4. We could, if we wanted to, we can express that for every increase of 4x's, the y value will increase by 3. So we can go over here and say, let's go over 4x's. Sorry, bear with me, there you Let's go over 4x's up 3y's. So from negative 3 over 4 puts me at 1. You can count it. And from 5 up 3 takes me to 8. So there's another point on my line. What if we decided that we can go back 4x's? Then the y values would go down by 3. That produces this result. Somewhere. There it is. And with that result, then we could see 1, 2, 3 points have been generated. One of them has fractions in them, so I filled the criteria. Hopefully you recognize that since I could restate my slope in any number of ways, I can find all the points that would fit on this line just by using different multiples of the slope. Now what we can do with this information is we could put a line through the points. And that line will be the line that we're trying to find. I could even estimate where the y-intercept might be. It's between 7 and 8. So if I count my slope over appropriately, then it's going to be over 1, up 3/4, over 1, up 3/4, over 1, up 3/4. It's a lot of counting by quarters. The other choice you have, of course, is you can go from 1/8, you go back 1, down 3/4. No matter how you slice it, you can find your y-intercept as 7 1/4. So that's the a value. B value is over here, 3/4. That's enough information to create the equation of the line. So the equation of the line is going to be 7 1/4, which is the y-intercept, plus 3/4 x. That's, again, up 3 for every 4, or up 3/4 for every 1. So this should be enough information for you all. Oh, by the way, don't forget to check your answers. So just to verify, negative 3, 5 should be a solution to my equation. I put in negative 3 for x, make sure that 5 is the outcome, and it is. The implications for you guys, we spent some time in class doing this, but this is on page 21, I believe. And in that page, you got 8 different lines that you need to find the equation for. And the first case is you got a slope at a point, and in the later cases, you're just given 2 points. But no matter how you slice it, you should have enough information to find the equation of the line by following this method. Once you know one of the points, you use your slope to count around and find all the other points and draw the line. And then use your slope to get your way back. I call it walking it home. Walk back to the y-intercept and find out what number that should be. And then, of course, check your answers. So I hope this is helpful. Have a good day.